Howdy folks, Mr. Reed here, and welcome to one more question. So what we're going to be doing today is polynomial times polynomial. I'm actually going to do it a little bit smaller than my mild case. I'm going to do a binomial times a trinomial, but I'm going to do it in only a single variable. So it's going to be something with a power 2 as the highest power of x and something with a power 1 as the highest power of x in my two different trinomial and binomial expressions. So what that's going to mean is in the end we'll have to do some collection of like terms in order to simplify things and make it look as good as we can. So if you're ready for a medium level polynomial times polynomial, let's get to it. Alright, so up above, binomial x minus 7 times trinomial, which is x squared minus 3x plus 5. I'm going to write that down. And I am going to get right into using the distributive property. So if you have not really had much experience with that, you might want to check out my mild video that comes before this. If you had, I'm going to go through this part relatively quick. So we're going to go right to saying every term in the first bracket multiplies every term in the second bracket. So that is x times x squared. So we have a single power of x with two power of x. The rule is when we have the same base that we add the exponent when doing a multiplication. So in this case, we're going to have x times x squared gives us x cubed. We move on to still first term in the first bracket times the second term. The order in which you do this actually doesn't matter at all. It's just that if I start jumping all around personally, I will likely either double up a term or miss a term. So I try as best I can to always just take the first term in the first bracket and go through everything in the second bracket and then start going through the second term and do the same thing third. In this case, I guess there's only two. But I try to keep some sort of order to it because if you just jump around, it's okay. You just have to make sure you hit everything once and you do not hit anything more than once. I had a prof that I sat in on a few lectures of one time that used to make it really, he was all about counting, and his idea was with counting is it's really hard to make sure you count everything once and only once. So basically don't miss anything and don't count anything twice. So we're going to try to do that here. So x times x squared gives us x cubed. Then we have x times negative 3x gives us negative 3x, and then x times x would be x squared. So then we have x times positive 5 is going to give us plus 5x, and then I'm going to move on to the second term, which is the negative 7. So negative 7, and again, if you saw in the last video, the way I treat that, we could say that the term is really just 7 on its own, but I kind of think of it as x plus negative 7, so I think of the term as being the negative 7. And that way I can carry the signs through with each individual calculation that I'm making. So negative 7 times x squared will be negative 7x squared. Negative 7 times negative 3x, multiply the negative 3 times negative 7, that's going to give us positive 21. And there's just the single instance of x there, so it's just positive 21x. Lastly, negative 7 times positive 5 would give us negative 35. So at this point, what I have to do is put together the like terms if I want this to be in the simplest form possible. So just kind of going through, we have one location where we have x cubes. We have two locations where we have x squareds. We have two locations where we have x's, and lastly we have a single location where we have just the constant numerical value, so just the negative 35. So I'm going to just take the parts that are the same, put them together, and so the x cubes, don't have another one. I have minus 3x squareds and another negative 7x squareds. So we're just doing integer, we're combining integers. So we have negative 3 and we have another negative 7. That's negative 10 of them. So negative 10x squareds. Next up, we have positive 5x's and we have positive 21x's, which means we're going to have positive 26x's. And lastly, we had just the negative 35 on its lonesome, so there it is. So that's what we do when we multiply, in this case, a binomial times a trinomial Again, the number of terms doesn't really matter. Just make sure you're getting every single term in your first expression multiplied by every single term in your second expression. Collect like terms when you're done, and you get a simplified expansion or answer to our product. All right, folks, if you found that helpful, like, subscribe, and as always, take care.